And as connected and autonomous vehicle testbeds sprout up around the globe, the policy, technology, and business challenges for connected cars become very real for service providers, enterprises, and consumers. And to sift through these problems and opportunities in the connected car space are a group of transportation and technology policy experts, all in one place at TIA headquarters in Arlington, Virginia, to discuss the best way forward for intelligent transportation systems. With us to recap these discussions during the TIA's Vehicle Connectivity Workshop and to offer the next steps for the connected car are four panelists. All the way on the end is John Bozzella. He's President and Chief Executive Officer, of the Association of Global Automakers. Next to him is Mary Brown, Senior Director of Technology and Spectrum Policy at Cisco. And next to Mary is Paul Najarian, Foreign Affairs Officer at the U.S. Department of State. And next to me is Jeff Stewart, Executive Director of Global Public Policy of Wireless External and Legislative Affairs at AT&T. Panelists, welcome to the program.
Thank you.
Thank you.
Thanks for being here. I know all four of you had a long day at TIA's Vehicle Connectivity Workshop, a number of sessions there. Before we get started, just really quickly down the line here, John, what was your impression of the workshop?
I thought it was a very productive day. Great dialogue, and really we're at an enormously exciting period here for vehicle connectivity, no matter how you define it. And whether you define it as telematics, or you define it as infotainment, or you define it as cars talking to other cars, we had a lot of discussion today about the intersection of consumers, private enterprise, and government policy. It was a great day.
Mary?
Fantastic timing with the new highway bill in Congress and also the announcement yesterday from the Department of Transportation about the new Smart Cities initiative. So I don't know who picked the timing of this, but they did a good job.
It was all planned. Paul?
I thought the bringing together the ICT, telecommunications, and automakers together under one roof was an excellent idea. A great platform to start, and also the timing of this right at the conclusion of the ITU World Radio Communication Conference was incredible.
Sure.
I'll echo my fellow panelists that it was a great day. It was a terrific event with a lot of good participation and good panelists. Timing also, it was good to see the interrelationship between vehicle connectivity and the broader Internet of Things, as discussed with Smart Cities and the initiatives that DOT is looking at, recognizing that it's part of a broader ecosystem overall.
Mary, I'm going to start with you, and you did mention the highway bill. This is a law that was signed by Obama just a few days ago, a $305 billion fund over the next 5 years for anything really IoT, right? And under that umbrella falls the intelligent transportation system. You said earlier in one of the sessions, this opens the floodgate for anything IoT. As far as ITS goes, what does it do for that?
So one of the interesting things about this bill, it's really the first time that Congress has put a heavy emphasis on technology in the course of the bill, and as we heard today, freed up the opportunity for state highway departments to put technology into roadways, in roadway projects, where it wasn't clear before. So not only do we have ITS funding for research and development and ITS projects to continue the development of that great technology, test beds and so forth, but we also have in the ordinary course of highway funding going out to the 50 states now the ability to put technology into the roads that's going to interact with these connected cars. So it's a tremendous advancement.
John, as you know, a number of stopgaps in the past to fund transportation projects, now a 5-year forecast for funding. How does that change sort of the climate?
I think it's a great question. I mean, look, we have some certainty in terms of funding. So this is great for, obviously, state departments of transportation, as well as all of us who depend on the infrastructure, whether you define infrastructure as the road as we understand it today, or the technology as is developing today and moving on to the future. We have some certainty and we have a little bit of continuity. I think the other thing, I just want to echo what Mary said, I think it's really important, which is that with the funding to support intelligent transportation systems, what you have now is you now have automakers who are already innovating and we're already putting technologies into the cars that allow cars to talk to other cars, with now the ability for state departments of transportation to invest on the infrastructure side. You can see products and services related to that technology blossoming. It's really exciting.
Paul, from the public sector, what was your take on the signing of this bill on Friday?
Well, actually, it's going to be more on the deployment side. We're going to look more on the vehicle-to-vehicle connectivity aspects. And we're going to hopefully look at a robust deployment and ubiquitous deployment, whether it's on the short-range communications aspect of it or the Internet of Things, some of the aspects of smart cities that were discussed. So we're looking more in terms of moving towards actual physical, robust deployment with this bill.
Jeff, private sector implications, especially on carriers, as far as the signing of the bill goes.
Sure. I think we're still certainly digesting the bill in full, but I think there are some very promising things for the allowances and movement towards deployment of the ITS technologies and some of the flexibility that some of the elements of the bill have. I believe Section 6004 actually acknowledges cellular technologies as a potential connectivity mechanism for advanced technologies and congestion management technologies. So elements like that facilitate sort of broader range of technological solutions in the mode of transportation is something that we certainly welcome and look forward to seeing come to fruition over the next few years.
And Jeff, I would just add that the bill has a specific provision in there about technology neutrality, which was very encouraging to see.
Absolutely.
Yeah.
Mary, I'm back to you. A lot of talk in these sessions at the Vehicle Connectivity Workshop about spectrum sharing really between automakers and Wi-Fi users. Cisco is in an interesting position. You are a Wi-Fi technology provider, but you're also very immersed in the connected car space.
Yes.
How do you handle both sides?
Well, we take the U.S. policy in the Dsrc space, the dedicated short-range communication space at 5.9 gigahertz, to be a given. Right? That technology has been in development for 10 years. There are various rules around it. The community has coalesced around a standard .11p. And so our idea with that radio spectrum, which sits adjacent to a current Wi-Fi band, is when the intelligent transportation uses are not in play, could Wi-Fi use that spectrum? Could we, in other words, detect when those transportation uses are using the spectrum and avoid them, but use them when they're not there? So the example I would use would be the suburban cul-de-sac at Wednesday night at 9 o'clock. You don't have a lot of cars or transportation happening on that cul-de-sac, but inside those houses, people are downloading, streaming movies, they're on Skype, they're, on the internet, emailing, et cetera, et cetera. So having that spectrum available, it would be a tremendous boon to Wi-Fi if and only if it doesn't interfere with the transportation uses that have been previously designated.
John, of the Association of Global Automakers, if you had to play devil's advocate on both sides of this argument, on the automaker side but also on the Wi-Fi user side, what were those two sides?
Yeah, so I think Mary summed it up really well. Let's start with the benefits. The benefits are extraordinary. We're on the cusp of producing significant improvements in reducing vehicle crashes and reducing highway fatalities. It's an enormous opportunity. The Department of Transportation estimates that we can affect 80% of non-impaired vehicle crashes with full deployment of this technology. This is an enormous opportunity for us, and so we have to get it right. And so the idea here is we're balancing both sides of a conversation that goes something like this. Let's make sure that we are able to produce with this technology the benefits that are expected of us by the Department of Transportation and frankly by consumers who, as we deploy this technology, are going to have an expectation that we're able to connect it with advanced vehicle safety systems and help them avoid crashes. So we're moving from crash management to crash avoidance. The key here is let's avoid harmful interference. And that's really what it comes down to. If we can figure out how to share that band of the spectrum without creating harmful interference with the current incumbent use of that spectrum, which is Dsrc communications for safety, then I think we're okay. And so that's the work that I think Mary and Cisco are doing a great job with, and I think across the ITS community, I think we're working fairly effectively on. But the key is avoid harmful interference and produce the value and the benefits that are expected from the deployment of Dsrc technology.
So you're saying, John, that possibly earlier the 5.9 gigahertz spectrum band was really considered to be dedicated to the connected vehicle sphere, but now it seems like automakers are much more welcoming of Wi-Fi usage of that band.
Yeah, I would say it this way. It was dedicated and is dedicated. Was and is dedicated to ITS purposes, right? The ITS functionality as the incumbent use. What the industry, I think writ large, not only automotive, but I think many aspects of both the automotive and tech communities are open to, is exploring and testing whether sharing can be used in that piece of the spectrum. That's really the question. Can it be done safely? And if so, can we demonstrate through testing that it can be? And then we have something to move forward on. But I think the most important thing is protect the benefits, the safety benefits, and then let's explore. There's great thinkers and great innovators and companies represented around this table. Let's understand what they're bringing to the table. Let's test it, and if it works, let's go forward in that context. But first, we got to protect the benefit.
Paul, wasn't the 5.9 gigahertz spectrum band really for safety and mission critical applications and never really specifically for any vertical?
Well, first of all, let's examine as to why the band 5850, 5925 was chosen to begin with about 20 years ago by the ITS industry. It was specifically chosen to piggyback on the adjacent UNII band that's used by the RLANs. And the idea was to take advantage of the synergies that are created both by the RLAN industry as well as the ITS industry. It is to deliver safety applications at 5.9 gigahertz. And just as Mary said, if it frees up, if there's applications, say, on the vehicle to infrastructure side, some of these applications that are non-safety related could be deployed using the UNII band. But for vehicle-to-vehicle communications, you would need the 5.9 gigahertz applications for the safety application that it provides. And among the synergies that was discussed even from the beginning in terms of was actually to look at the deployment side. The big picture was, who's going to deploy the infrastructure? Is it going to be the state DOTs, or are there going to be the local communities and so on? So the partnership between the ITS and the RLANs was the absolute key to deploy the infrastructure side of this equation. The vehicle-to-vehicle side of the equation will be deployed by the car manufacturers, by the global automakers, etc. The bigger picture is the vehicle-to-infrastructure side, which is where the synergy is absolutely a must to deliver the services for both industries.
Let's talk further about that. Let's talk about CV test beds and the synergy that you talk about between the public and private sector. What is the current climate of that synergy?
Well, obviously, where we see the act that was signed yesterday, there's going to be a lot more funding available. What we heard this afternoon, the additional $50 million that's available for smart cities deployment. So these are the types of examples that are going to kickstart and hopefully help the state and local municipalities that have funding issues to deploy the infrastructure side. So it has to work based on a public-private partnership which involves the automakers, the state DOTs, the ICT manufacturers, etc.
Jeff, any comments on this synergy between carriers, the private sector, and the public sector in this space?
Well, I think we certainly look forward to participating, particularly as Paul mentioned with the Smart Cities initiatives. We see that as both the ITS world, the transportation world, and smart cities, as well as others, as segments within the broader Internet of Things. And we see a lot of federation going on across those segments that are ways that communications providers can provide interconnection and communication across and between those segments. So I think that test beds in the transportation world and things like the Smart Cities Challenge are ways that are opportunities for us to work without that federation and work out some of the technological development where larger and broadband connectivity providers, network providers can play a better role there.
I want to talk to you a bit more about the challenges with these test beds. I'm sure you're privy to some of these challenges. I would think maybe from a consumer standpoint or even from an enterprise standpoint that those challenges would be around maybe security or spectrum sharing or transitioning from 4G to 5G or 3G to 4G. What are the challenges that you're seeing as a carrier?
Well, I think our work to date has been very focused on getting embedded cellular connections into vehicles and driving consumer adoption of those. Consumers are beginning to see the benefits of that connectivity that provides them, particularly with infotainment services they receive in the vehicle, as well as repair and diagnostic services that the manufacturers can provide to the vehicle owners that way. We're having worked on that for the last few years, and I think we've made good strides. We've got 5.8 million vehicles now connected to our network. and that's growing rapidly. I think that we see now the opportunity to move forward with broader forms of connectivity and, like I said, sort of that federation across various Internet of Things sectors or segments where we can begin to expand that value presented to the consumer. As far as the role with test beds and things like that and driving consumer adoption, certainly those test beds will help prove out things, concerns about security and privacy that could be barriers to adoption, both on the consumer level as well as on, there's issues to be worked through and thought through on technology and policy levels as well. And those tests are crucial to proving this out and inculcating the consumer confidence that can drive the adoption of those technologies.
Jeff, you did mention Dsrc for our audience. I'd like to go ahead and have one of you describe that for us, and then we'll get to another aspect of a discussion we had earlier in one of the sessions at the workshop in just a moment. Mary, I'm going to look to you for a quick abstract or definition of Dsrc.
So dedicated short-range communications describes communications in 75 megahertz of spectrum, starting at 5850 megahertz up to 5925 megahertz. That allows both vehicles to talk to other vehicles, V to V, as well as vehicle to infrastructure communications, V to I. And it's not just a radio technology, although it is a radio technology in the US. It's an 802.11 technology. But it's also a series of defined channels with very specific assignments. So there's one channel that is going to be used for the cars V to V to talk to each other. There's another channel in the middle that's going to be used to control the system. It's a control link. There's a channel up at the high end of the band that allows state highway departments to communicate. So there's very defined uses in this spectrum that are the product of years and years of work by the U.S. Department of Transportation, NHTSA, and the automakers and others to define what this stuff looks like.
There was some discussion during one of the sessions at the Vehicle Connectivity Workshop about an either-or between LTE technology and Dsrc technology. Whoever brought that up was soon corrected that it's not really an either-or, it's more of an overlay or coexistence of both technologies. Jeff, I'll let you add on to that.
Sure, I think that LTE technology, cellular technology overall, can be complementary to the Dsrc technologies and the suite of applications that they'll provide. We're certainly seeing more rapid adoption of the cellular technology in vehicles. It's been a little quicker to deploy, sort of following the more rapid technological development process in the ICT world. But I think they are complementary, and there's both some functions that were originally envisioned as Dsrc functions that may be able to be provided by LTE. I think the industry writ large is in early stages of examining how that might be. And there's also early stage standards work going on in 3GPP and some other standards organizations on how to adapt the LTE standards to provide some of the capabilities that could complement Dsrc or replace them in some certain circumstances. That work's going to be going on for a long time, and as we have an eye towards 5G and 5G standards development, that will continue. I think you'll see sort of an intermeshing of those capabilities in vehicles as they're deployed.
John, the highway bill being signed on Friday, what direct impact does that have on the deployment of Dsrc technologies and really the adoption of that as well?
Yeah, it's another step in the path, the inevitable path toward deployment. Let's step back and see where we're at. Right, we have these test beds, the pilots and test beds that are really sprouting up across the country. And what's happening is, both Mary and Jeff talked about different technologies that really, as from an automaker's perspective, create a web of communications, right? Different pipes in and out of the vehicle, that create a web of connectivity for the vehicle. They have right now they produce different benefits and they're used for different things, but that will continue to evolve, and that's a big reason that the test beds are critically important. The other thing that's really important to focus on with the CV pilots, which I think is really exciting, is we're not only testing the technology, we're also testing business models. And we're thinking very, very carefully already about what the innovation does for consumers, right? So we're moving at the same time towards sustainability. So again, the work that's being done by DOT and that's been done through the Joint Programs Office, the work that's being done at the National Highway Traffic Safety Administration to create a standard and a rule that allows for vehicle manufacturers to install Dsrc technology, the test beds that allow this to be tested and for consumers to gain confidence with the technology, and then ultimately for us to develop products and services that produce value, benefits, and frankly, opportunities for investors is all happening, and the highway bill contributes to that through the continued funding of ITS.
Paul, I want to ask you about the security and reliability of Dsrc platform and protocols. Isn't Dsrc technology reliant on the secondary network? It's not self-reliant. I heard really two things said on a couple of sessions, that as long as you implement the hardware, the Dsrc hardware within the vehicle, that it's almost autonomous, it's almost self-reliant. And then someone else said soon after that it's actually at the will of a secondary network. I was confused personally. I'm sure you guys weren't. Can you explain that to me?
Well, first of all, it is dependent on a backhaul network that is going to deliver the data to the vehicle, or from a vehicle to vehicle, it is subject to any type of cyber attack that could exist, or any type of interference, radio wave interference type of issues. Now, the discussion that was held was about the over-the-air updates of the software that's in the vehicle, and that's one area that within the ITUT is being looked at as to how the software can be updated via over-the-air mechanism to keep the software updated and to keep preventing from hacking attacks and so on. But what was interesting also is that the DOT mentioned that so far they have not witnessed any type of such attacks that based on the public notice that they had released through NHTSA, and they had not found any type of not even any anecdotal evidence about that.
So John, if I want to utilize or leverage Dsrc technology in my current vehicle, I don't have the finances to buy a new vehicle, is that a software implementation of Dsrc, or does someone have to come and install hardware in my vehicle?
I think what you'll find as this process develops is you'll see aftermarket providers provide Dsrc technology. So a device, a technologist might call it a radio or a transponder or a transceiver. A device could be purchased on the aftermarket that would give a product existing in the marketplace today that type of connectivity. In other words, it would be able to send and receive a basic safety signal that Mary talked about a few minutes ago, and then a simple warning to the driver and the occupants of the vehicle about its relative direction relative to another vehicle's direction. You could see ultimately potentially an integration of that type of aftermarket device into the active safety systems of the vehicle, although I would say that probably happens by the original equipment manufacturers, by the automotive manufacturers to begin with. And so you'll see a mix of more integrated products being built by car makers as coexisting in the marketplace with aftermarket devices that would be in cars. And so that's how you get to a critical mass, right? So you're able to produce value for consumers more quickly. You're able to work with infrastructure providers to create benefits, products, and services based on that connectivity, and we grow and develop these networks more quickly. So I think there's a very, very real opportunity for aftermarket providers here.
There's also an opportunity for aftermarket providers in cellular connectivity. We have several products in the market, as do others, that allow you to retrofit your car that has no BD2 port with a cellular connection and derive some of the benefits that you would otherwise only have to have an embedded cellular connection for.
Mary, when we think of, again, from a consumer standpoint, we think of security within a connected vehicle, we think of maybe hackers, black hat hackers, white hat hackers. But there's also another side to security within the connected vehicle. Those vehicles collect a lot of data, right? You want to keep that data private. What are some of the challenges around privacy in the connected vehicle?
Well, the main challenge is most of the rules have yet to be written. So one of the things we saw in the highway bill is that the data associated with an event or a traffic accident in your car is yours. The bill has declared that the owner of the car or the lessee of the car owns that data, right? So we got that pronouncement. We know that that NHTSA, in their upcoming decision on Dsrc next year, has asked a whole series of questions about privacy and security and what the rules of the road should be, so to speak, with respect to the consumer data coming out of that car. So we're going to learn more when NHTSA finally releases their decision next year. But these are very important issues which have been vigorously briefed to NHTSA in their proceeding, and I assume will continue to be the subject of policymaker concern going forward.
I'd love to add to that, and I think Mary's done a great job of outlining what's in the bill. I think that in private enterprise, we have responsibility as companies and associations to take action ahead of regulation and ahead of legislation, and that's precisely what the auto industry did. So well over a year ago, and these were announced a year ago, we developed a series of privacy principles that each major automotive manufacturer doing business in the United States signed up to and committed to about how we treat personally identifiable information, important data about drivers and passengers of vehicles.
Is that ISAC?
No, this is before we got to cybersecurity, this is about how we treat data. So for example, we took 3 types of data that we think customers feel are very important to them, and we treat them as sacrosanct. They're geolocation data, where I'm going, where I've been, right, and how I've gotten there. Biometric data, how I sit in the vehicle, how big I am, what my eyes are doing on the road, right, as well as driver behavior data. Do I slam on the accelerator and have jackrabbit starts and slam on the brake and stop? Do I start my car in the morning and go in and get a cup of coffee and then come back? The car can collect that type of data, and what we've said to consumers is that we're not going to market that data without your permission. We're not going to sell it to third parties, and if somebody wants it, they're going to need a court order to get it. And so we've been very careful about treating that and this is why. If we're going to move forward and produce these benefits for consumers have to feel confident, and they have to feel that they're in a trusting environment. And so we have to do our part. These are the beginning. We'll have to do more, we'll need to do more, but this is a really good foundation. So this, with regard, and then what the policymakers are doing are important steps. And we can talk further about what we're doing on the cyber piece, but that's what we're doing on privacy.
We certainly welcomed the auto industry's approach there with their privacy principles, and it's something that privacy is one of those overarching issues for the Internet of Things that as a player in all those spaces, we see the same issues pop up. And one of the great challenges, I think, for policymakers is ensuring that there's a coordinated approach across those segments so that you don't have conflicting regulations or regulatory approaches or significant gaps in consumer protections. And I think that the voluntary industry-based approach has been successful to date. We've participated in many other ones. There's CTIAs, location-based services privacy guidelines. There's smart grid privacy guidelines that have all been industry-generated. So the auto industry is another one that joins that. And those provide a mechanism then that an enforcement agency like the FTC can provide the backstop for consumer protection, provide that trust and confidence for consumers to help spur adoption without having overweening sort of sector-by-sector regulation that gets into that realm where you either have overlapping, conflicting, or duplicative regulation that can impede the development of products and services.
And we saw that actually in the panel discussion of the test beds, because what we saw there, we saw 3 different models. One from the VDOT, the other one for the Michigan test bed. Some of them with different volumes, some of them involving commercial vehicle applications, some of them involving large number of vehicles. But at the end of the day, the challenges about data was the only common issue across the 3 test beds. And what to do with the data, where to store it, what kind of a cloud scalability do they need, what kind of privacy issues do they need, how to dispose of the data, how the ownership of the data. And all of those lead to the type of confidence that the driver needs to have when they have, especially when they have a Dsrc equipment in their vehicle.
So in staying with the theme of this panel, the next steps for the intelligent transportation system sector, if you will. I'm going to go down the line here. John, I want to get from you, again, someone in one of the sessions asked, where do you see ITS in the next 3 or 4 years? I'll pose that question to you.
So I think it's about accelerating the benefits. I think it's about moving in from testing and research into deployment, and it's about accelerating those benefits and bringing consumers along on a very exciting ride.
Mary?
I agree, and I think industry writ large, everyone involved in this ecosystem, is going to need to highlight those benefits to consumers. If we can highlight the benefits to consumers, we are going to accelerate adoption. And I'm mindful of another IoT example. When the electric utility industry rolled out their smart meter programs, they got a lot of consumer pushback because consumers couldn't see the benefits. And I think one of the most exciting things about ITS is consumers are going to be able to see benefits. and we're going to be able to talk about those benefits and point them out.
Paul?
Well, first of all, ITS was launched back in 1995. And in 1996 at TRB, the Secretary of Transportation, Federico Pena at the time, announced the national ITS architecture. Today, 20 years later, ITS is now mainstreamed into everyday traffic operations, whether it's the Internet of Things, smart cities, and so on. And what we have seen over the last 20 years, we've seen a tremendous progress in terms of integrating information communications and technologies into the transportation infrastructure. And so we've now moved away from the deployment, and we now see a mainstreamed ITS throughout society.
Jeff?
I think we'll see picking up of the pace of technological both development and deployment, and a much greater awareness of the consumers, as the other panelists have talked about. I think that probably the consumer-facing things are going to gain mind share of the consumers first, and then the broader ITS benefits will probably come along a little bit after that, after the awareness of consumers is raised. But consumers are beginning to understand that everything in the world is being connected, and they're going to expect nothing less from their cars. And so I think that will help spur their adoption and acceptance of the new technologies that are coming to transportation.
I think the TIA Vehicle Connectivity Workshop was really a success, and in large part to you guys showing up. So I know that our audience here at TIA headquarters really appreciated your time and your expertise, but also our folks watching on the live feed as well. So John, thanks for making it, giving us your time. It was also nice meeting you.
Thank you.
Mary, it's good to see you again. It's been a few years.
Yes.
Paul, it's good meeting you. And Jeff, nice to meet you as well.
Thank you.
Thanks so much.
Pleasure.
Yeah.
Thank you.